how do we hear sound? Well, how are you able to hear me right now? Let's break it down. I'm making sound waves with my throat and mouth, which is being stored digitally from a microphone to an SD card, and that digital file is probably being played through to a speaker or headphones wherever you are. Slow down, man. Where does sound really start?
In physics, there are three main elements to create a sound wave. First is a source, or where the sound is coming from. Then, the amplitude, how loud the sound is, measured in decibels. And finally, frequency is how often the sound occurs, measured in hertz.
Now the source begins with a vibration, pressure, or displacement of any matter, and is transferred to us through a medium, which is most commonly air. When that vibration is in the air, sound moves in a longitudinal wave, or compression wave, to reach our ear.
Now in science class, you probably remember transverse waves, or the waves like in an ocean. But sound is a longitudinal wave, which travels in the direction of propagation, or parallel. So with these two red pieces of tape representing air particles on the slinky, a transverse wave directs the air particles in a right angle of the direction of propagation, where there are peak points and low points for the air particles. Longitudinal waves, however, compress the air particles together and send the wave parallel to the propagation. Now that we know this, we can begin to understand how sound is replicated from something like a speaker.
Also, when looking at the waves, the number of ridges there are represent frequency, and like we said in the three elements that create sound, frequency is how often the sound occurs. Now here's an example you can do to test frequency. Hold your throat and go from a low note to a high note and feel the change in vibration. And you can feel that your throat vibrates more at the higher note. Now an example to demonstrate how the mass of an object affects its sound is with two different size metal containers, one being very small, the other very large. So let's see the differences in sound they make. So if sound is simply moving air, then the bigger the object, the more air it moves, which causes a louder and deeper sound due to more air molecules being compressed. Another key element in sound is echo, and when I clap in a large open room, the sound waves reflect back to my eardrum from the parts of the room that they travel to. Now the reason sound eventually stops is explained in Stokess Law of sound attenuation, which states that the amplitude of a sound wave decreases exponentially with distance traveled. But let's take a closer look at this law. Stokes' law of sound attenuation. The word attenuation means to weaken or reduce in force. So, unlike light waves in space, there's a point where sound cannot be heard from a certain distance. And maybe you heard the saying, if a tree falls in a forest and no one is around to hear it, does it make a sound? Well, yes, but the vibrating air particles attenuated before they could reach anyone's ears. But why is that? Sound can't travel through empty space, and like we said before, sound is carried through its medium of air particles. But how is light able to travel through a vacuum, or empty space? The reason is because light waves don't need a medium to travel through, and light waves almost act as if they had inertia, only without the mass. They just continue in their existing state of uniform motion. A cool thing to remember is that sound travels slower in a medium of water, and even slower in a medium of gas. But there is one exception.
Helium.
The reason why is because sound travels 1,128 feet per second through air particles, but in helium, sound travels up to 3,041 feet per second. Although sound is seen as a form of energy, we use it for enjoyment, to vibrate our eardrums with the music that we listen to. And although I could wear out my own diaphragm explaining this concept of sound, I'll leave you with this. The next time you're blasting your favorite song, don't just listen to it, think about it.